So let me go back to that earlier example, PbCO3. The proper way to name this compound would be name the metal, put the charge of the metal in Roman numerals with no space. There's your Roman numeral 2, and then put a space, and then state the name of the polyatomic. In this case, it's carbonate ion. So you'll memorize or have a chart of these polyatomics. This is made up of a lead ion and a carbonate ion. So it takes a little bit of practice to know how to split up the formula and recognize what it's made of. I know you always look at, if you're not sure what the lead ionic charge would be, because lead is in the middle of the table right here. So it is part of the transition metals. It's kind of over here, but anything in yellow is considered behaving like a transition metal. It can have more than one possible charge. And there's no way to predict its charge because it's under the fourth column of the main group elements. So it is a little confusing on what that would be. So, but you can easily figure it out because you can look at the thing it's bonded to. In this case, it's bonded to a carbonate ion, which you'll know is -2, and therefore it must be a +2 because the total positive charge would balance the total negative charge. They always add up to 0. Now there's a older system that we use to name compounds like this, and it comes from the Greek and Latin names for these elements. For instance, if you look at the compound SnCl2, it also forms, there's a compound SnCl4, so we have to have a way of distinguishing those. In the newer system, you'd name the metal first, it's tin, and it has a +2 charge because we know chlorine is -1. That's a -2 overall. That must be +2. So you'd put a Roman numeral 2 with a space and then chloride like that. This would be tin 4 chloride. So that's the Roman numeral that looks like that. 1V, so to speak, with no space, and then a space and the word chloride like that. Now, there's an alternative way. The word for lead or tin is stannum. I think that's a Latin word. And oftentimes we name metals in this system by taking the Latin or the Greek word and dropping the last couple letters and adding a new suffix. So if it's an Sn +2, we add the word O or the suffix OUS. So it would be stannous ion. And the ion with the higher charge, Sn4+, would take the base Latin or Greek name and add the suffix IC. So you're either adding the suffix OUS to the lower charge, or you're adding the suffix IC to the higher charge. And those are ions, of course. And so the alternative names for these compounds, this one would be SnCl2, in the older system could be called stannous, and then a space chloride. And this one would be stannic chloride. Both systems of naming compounds is acceptable for you to use in this class. It's probably more common to use the more modern system, but I would like you to be familiar with that system as well. So let's give you some more examples of this older system. So copper +2 is the copper 2 ion, but it's comes from the Latin word for copper is spelled C-U-P-R-U-M, cuprum. So you drop the UM and add either the IC or the OUS ending. So since copper is either commonly a +1 or a +2 ionic charge, the lower charge gets the OUS ending, cuprous, and the +2, the higher charge, gets the IC, cupric ion. That goes for all metals. Iron is from the word ferrum, F-E-R-R-U-M. So it's the lower charge, in this case, is +2. The higher charge that's common is +3. So iron +2 ion would be ferrous ion, and iron 3+ would be ferric ion. So you could name a compound, for instance, as iron 3 chloride, or it would be called ferric ferric chloride. Iron 2 chloride would be alternatively called ferrous ion. It's important to remember that there's no Roman numerals needed for metal ions in the main group. So we don't need to use Roman numerals for sodium ions, potassium, lithium, calcium, magnesium, strontium, or aluminum. We just name the metal name and the word ion. And again, there's two positively charged polyatomics that are common. One of them is the NH4 ion, which we call ammonium ion. And that will be discussed a lot when we just talk about acids and bases. And the hydronium ion is another common ion that's positively charged. But the vast majority of them are negative charges. And I'm going to review a lot of this with you. So let's just go back and summarize what I've kind of been running rather quickly through. Anions are named by replacing the ending of the element name with IDE. So you can see a lot of the common ones of the monatomic ions are named from the parent element name and just change the ending to IDE and add the word ion. That's pretty simple. Polyatomic ions, again, ignore this 4.9. This is from another textbook that I used. This seems to give students the most trouble, so I want you to spend some time to clarify the difference and to understand the difference between a monatomic ion, a negative charge, and a polyatomic ion. So they're composed of more than one atom, and they are mostly contain oxygen and some other element. And most of the nonmetals that they contain are sulfur, nitrogen, phosphorus. Sometimes they contain even halogens. For instance, sulfate ion is composed of 1 sulfur and 4 oxygen atoms and carries a -2 charge. So we write it as SO4 -2. But there's another ion called sulfite that has this SO3 with a -2 charge. There's a polyatomic that's common that's NO3 with a -1. There's one that's NO2 -1, and so on. So you can see it quickly can get rather complicated with the polyatomics. Each element can have more than one polyatomic. Sulfur forms 2 common ones. Nitrogen forms 2 common ones. Phosphorus forms 2 common ones. They're all combining with oxygen. The halogens form these polyatomics that have 4 possibilities, either 1, 2, 3, or 4 oxygens. So we have to come up with a way of naming these things that I'm going to review with you a little bit here. So how are we going to do that? Well, let's come back to that in a little bit. Let me just give you some more of the common polyatomics. I'll give you a chart in class that you can use, and there's also one in the textbook. I haven't figured out or decided if I'm going to make you memorize these yet or not. I'll kind of see how it goes in discussion. But some of the common polyatomics you'll learn and probably memorize anyway are these. There's one called the OH, that's called hydroxide. There's one called nitrate, you just saw on the earlier piece of paper. Carbonate is very common. You can see, if you're looking at the names here, you can see, well, that contains nitrogen, so it has the prefix NITR. This contains carbon, so there is some logic to this. It isn't just random names. But the number of words you're learning can be intimidating, so you just need to practice this. We're not going to worry about how they actually are structured at this point, but you will, in a week or two, learn how to actually draw these out. But memorize, at least for now, or use the charts to keep track of the polyatomics and how they're named. Let me go back now to the polyatomics that contained halogens. And so, for instance, chlorine forms a group of polyatomics, not just 2, but it forms up to 4 of them. I'm sorry, I wrote that wrong. Let me try again. ClO, they're all negatively 1 charged. So you can either have 1, 2, 3, or 4 oxygens bound to it. And this goes for bromine as well, and for fluorine. They form families of ions as well. And these actually have other polyatomic sort of partners that they form as well, and I'll come back to that. So how do we name these? Well, let's see, it's a little tricky. This one, for instance, is called the chlorate ion. Now, because it contains chlorine. But now, how do we name this one? So you're going to name that in a similar way, but you're going to add a new suffix to it. So since this one contains one fewer oxygens than this one, we change the ending to ite. We give it the name chlorite ion. This one contains one less oxygen than the chlorite, so we had to come up with a way to specify that uniquely. So there's a prefix hypo, like you're hypoglycemic, you have low blood sugar, or you have low blood pressure. You have hypotension, not hypertension. It's the prefix hypo, so we add that. That means less than. Hypo is one less than that, so we call it hypochlorite ion. How do we name this one that has more than than the chlorate? Well, we use the prefix hyper, but we drop the HY. We don't call it hyperchlorate, we just call it perchlorate. So there's all these subtle little rules you have to practice and learn about. And that goes for there's a family of ions, BRO, BRO2. At least they have one thing in common, they're all negatively 1 charged. That would be hypobromite, bromite, bromate, and perbromate ion. Going back to just as important or possibly more important for naming polyatomics is how you'd name polyatomics that come in pairs. So there's some common pairs. There's this one, NO3 -1, and then there's NO2 -1. There's a common polyatomic, of course, that one, and then there's another one, that one. Why these have -1 charges and those have -2, don't worry about right now. You're just accepting that and learning the names. So this contains nitrogen, so they are going to be have a name that contains that, nitrate ion. Now, the convention we follow is when the polyatomic has one fewer oxygens, you give it the ITE ending, just like we did over here with these. That contained, this contains one fewer oxygens than this one. So this gets the one with the lower number of oxygens gets the ITE ending. The one with the more oxygens gets the ATE ending. Same thing here. It's a relative thing though. These contain 3 and 2, and these contain 4 and 3 oxygens. So it's just a relative indication. More oxygens here, nitrate. One fewer, nitrite. This one contains sulfur, so it contains the SULF. This is called sulfate ion. This contains one fewer, so we call that the sulfite ion. So please do your best to memorize these names of these polyatomics and then practice using them in formulas. And in the next part of the video, I'll give you some examples. So let me run through and give you some more practice with naming these things. Let's assume you can write the formulas correctly and recognize that they are ionic compounds, so then you know the rules you're going to follow. Name the metal first, followed by the nonmetal, whether it's a monatomic anion or a polyatomic ion. This first one, you would say, okay, that's contains a calcium ion. We don't change the ending of the metal. And then we put bromide for the fact that it contains a bromide ion, 2 of them. 2 of them are needed because that's each one is -1, and that's +2. So it balances out to add to 0. I'll assume you understand all that at this point. Let's just practice naming these. Now this one is CaSO3. If you look here in this chart of polyatomics, that's the sulfite ion with the ITE ending. So you don't have to change the ending of a polyatomic. That's just calcium sulfite, done. Aluminum and oxygen, that's a binary ionic compound because it just contains two different elements. So aluminum oxide. Now this one, is a polyatomic with aluminum, so no need to change the ending of the polyatomic. That's aluminum phosphate. Now this one has a transition metal in it, so we can call that iron, and it's iron 2 because it's bonded to 2 of these. Those add up to -2, and then we change the ending on the chlorine to chloride, iron 2 chloride. The alternative name for that would be, remember, iron comes from the word ferrum, so that's the lower charge that iron forms commonly, so that would be the ferrous ion, so ferrous chloride would be the alternative name to that. This is iron 3. Notice I'm not putting a space, as I said before, between the metal's name and the parentheses where the Roman numeral is. So that would be iron nitrate. The alternative name for that would be, since that's iron with the higher ionic charge than this one, that gets the IC ending, so that would be ferric nitrate. And this one here is chromium, and hydroxide ion is -1. Since there's 3 of them, there must be a +3 on the metal. So that's chromium 3 hydroxide. And the chromium forms 2 common ions, Cr2+ and Cr3+. This could also be called chromic hydroxide. So here's a few more common polyatomics I'd like you to know and be familiar with. This is called the acetate ion because it comes from acetic acid. It has this common structure. You might see it drawn sometimes as C2H3O2. They both have the same meaning. This is the bicarbonate ion, HCO3 -1. It's also known as the hydrogen carbonate ion. CN with a -1 is the cyanide ion. MnO4 with a -1 is called permanganate ion because it contains manganese. They're part of the name. Another common one is what's called bisulfate ion, HSO4 -1, also known as hydrogen sulfate ion. So these other alternative names for this one and for this one just state it kind of what it's made of, hydrogen. So it's hydrogen sulfate or hydrogen carbonate ion, but I always call that bicarbonate and bisulfate, which is a slightly older name, but both are correct to use. So you can see there's a lot of polyatomics to use and to know. Some of the common uses of ionic compounds: calcium carbonate is in chalk, it's marble, statues are made of calcium carbonate, can be used as an antacid. They have all sorts of applications. Ammonium carbonate is used in smelling salts. Lithium carbonate is the lithium you might have heard prescribed for depression. NaOCl is sodium hypochlorite, which is the common ingredient in laundry bleach. Potassium nitrate is commonly used in gunpowder or as a desensitizer for teeth. In Sensodyne toothpaste, you'll see it's usually a 5% solution. I believe it's 5% of potassium nitrate. So there's all sorts of uses for ionic compounds. Now, another common compound, it isn't exactly an ionic compound, but it behaves like an ionic compound, so we talk about it now, and those are acids. They come from polyatomic ions, but they contain hydrogen. So I want to go through some of the common acids and how we name them. So there is a acid you might see me draw in class 3 different ways. I might write it like this, HC2H3O2, but if you see on the earlier page, that is the acetate ion, C2H3O2, or it might be written as HCH3CO2. That's not exactly a common way. It might be written as CH3CO2H or CH3COOH. Again, I'm going to use all of these, so I want you to be ready to, be a little flexible in how you interpret these formulas. That's an acid called acetic acid. I don't necessarily want you to memorize these, but just recognize when you see the formula of an acid. This is called carbonic acid. And just like we name ionic compounds, there's always a space between the first word and the word acid. Now, you recognize these as acids because they contain hydrogen written first. This one didn't contain hydrogen written first because it's an organic acid, so the structure is a little bit different. That's why I sometimes wrote it like this, or HCO2CH3 would also be an acceptable way, slightly confusing, so I'll try to stay away from that way to write acetic acid. These will be by far the more common ways to write and draw acetic acid. Another very common acid is nitric acid. Sulfuric acid, H2SO4. Extremely common chemical. There's phosphoric acid, which is used in soda. And then you have acids that come from halogens. You have HCl, which is hydrochloric acid. You have HBr, hydrobromic acid. And you have HF, which is called hydrofluoric acid. Fluorine is spelled F-L-U-O-R-I-N-E, not fluorine, it's fluorine. So I want to review with you where did these names come from? How did we come up with these names? So let's take acetic acid and break it down a little bit. So that's HC2H3O2. Now, if you break it down into its two pieces, you'd have a H plus and you'd have a C2H3O2 piece. You break it apart exactly in the same way as you break apart sodium and chlorine to interpret the structure. That's consisting of a sodium ion and a chloride ion. It's a positive and negative charge. It's an ionic compound. This behaves like an ionic compound too because it's made up of a positive and negative charge. But the way we name these acids is a little bit different. What you do is you recognize that the acid contains this ion, which is called the acetate ion. So therefore, when the ending of the polyatomic ion that's contained in the acid ends in ATE, you change the ATE ending to an IC space acid. That's why it's called acetic acid. I changed the ATE ending to IC and added the word acid. So that applies to this compound, H2SO4. You recognize that's an acid because it has hydrogen written first. If you break it up into its constituent pieces, it contains two hydrogen ions and a sulfate ion. Again, look, they add up to 0 overall. And this is the sulfate ion. So it ends in ATE, therefore it becomes an IC acid when you name it as an acid. And so this is it's not sulfic acid. This is kind of what I mentioned earlier in one of the videos where you have to change the name of compounds a little bit sometimes when you're naming them as something slightly different. So we don't change the ending of this word to IC, we change the name of sulfur, the element sulfur that's contained in this compound, and then we add IC, so it's sulfuric acid, maybe because they thought the word sulfic sounded a little funny. And then there's another acid that's related to that. It's H2SO3. It looks a lot like sulfuric acid. It contains two hydrogens, but it contains a sulfite ion. So this, if you break it down into its pieces, it's two hydrogen ions and a SO3 -2, which is the sulfite ending in ITE ending. So something that ends in ITE becomes an OUS acid. So the name of this compound would be not sulfuric acid, but sulfurous acid. Sorry about that. Okay, the only way I can I can best illustrate that is to give you more examples. So to illustrate that, what I just showed you here would be to give you these two examples. There are two common acids, HNO3 and HNO2. This is, let's break them down into their pieces. That's made up of H plus and NO3 minus, and this is made up of H plus and NO2 minus. Well, the name of that ion is nitrate ion, and the name of this ion is nitrite ion. So the general rule that you follow is the ATE becomes an IC acid, and the polyatomic that ends in ITE becomes an OUS acid. Sorry, I'm writing quickly and somewhat sloppy. So then therefore this one, this compound is nitrate. We would call that nitric acid, and this one ends in ITE, so HNO2 would be called nitrous acid. What would the name of this formula, what would the name of this compound be? Well, you do the same thing. H3PO4 means it's made of 3 protons, hydrogen ions, and 1 phosphate ion. Well, that's called phosphate ion. So it ends in ATE. So the name of the acid, you change the ATE ending. But now again, just like we did for sulfuric, even though the polyatomic is called sulfate, the acid that contains that sulfate is called sulfuric acid. Same thing here. This compound is an acid that contains the phosphate ion, but when we name it, we use the elemental name phosphor prefix and add the suffix IC and then the word acid, phosphoric acid. Let's keep going with more examples because I think it's the best way to review this with you guys. This one contains 2 protons and the carbonate ion. So it ends in ATE, therefore when you name it, it ends in IC, carbonic acid. I think you get the picture. Now the other common acid are acids that contain hydrogen but just a halogen, like that one, or this one, or this one, or that one. Those are the common halogen-containing acids. Now those are named a little bit differently. The rules are slightly different. So this is made up of a hydrogen ion and a chloride ion. This is made up of a hydrogen ion and a fluoride ion, hydrogen ion and a bromide ion, hydrogen ion and an iodide ion. The formula is all pretty simple because it's just a positive 1 and a negative 1 charge, just like sodium chloride. But they contain hydrogen, so we recognize that they are acids. So there's a way to name these. Now there's actually 2 ways to name these. We're naming them as acids right now. So this won't necessarily make a lot of, it won't be totally clear to you, but you recognize them because usually as acids because we have this little, we put a parentheses AQ after them to imply that they are dissolved in water. That's how I know that that's an acid, and you will too. So when you name it as an acid, we don't just change the ending of the ion to chloric or chlorous acid because that would be confusing. That would be a different structure altogether. So they had to come up with a different set of rules for naming compound acids that contained what are called monatomic anions. All these acids I've given you so far contain polyatomic ions in the name, in the formula. These acids contain monatomic ions, these guys, monatomic, which are 1 atom, 1 ion by themselves. So the way we do that is the rule we follow is we say we take the prefix hydro and we add the name of the halogen. In this case, it would be hydrochlorine, and we add IC acid, just like we did with sulfuric. We add IC acid. This one would be called hydro, to imply that there's a hydrogen in it. Fluoric, Fluoric space acid. This one would be called hydrobromic acid, and this one would be called hydroiodic because it contains the element iodine acid. But they all have something in common. They all have a first word and then a space and then an acid. So when you read that in somewhere, you will understand that that is a compound that has hydrogen written first in the formula. That is a little bit confusing, but in the next video, I'm going to kind of give you a flow chart to summarize all these names and compounds I've given you to show you how they all kind of fit together.